Alright everyone, so here we are for the Chapter 6 material. The main thing in Chapter 6 is we're going to start using the normal distribution more so than just what we learned with the empirical rule, but it's a good idea just to see the empirical rule to start. So this is the normal curve. It technically goes on forever, but essentially the majority of your data, or almost all data, will be covered within 3 standard deviations. 95% will be covered between 2 standard deviations, which is where we again get that range rule of thumb of your mean plus or minus 2 standard deviations. Between plus or minus 1 standard deviation, you get 68% of the data. And of course, that also means the entire left-hand side is half the data, the entire right-hand side is half because it's symmetric. And so, there we go. What we're going to do is we're going to move from just using the empirical rule to using or finding more exact measurements for our data. So really, the problem is, what if I have a z-score that's not exactly -1 or +1 or -2 or +2 standard deviations away? How can I determine how much area there is? And so one way we can do that is by using a table. So I've got your homework tables pulled up here, and one thing just to say early on, remember that STA2023 will be available. We'll find a way to use it, but let's take a look at this table and see what it has. I see a picture of the normal distribution with some line on it, some z line, and there's some z right here on the left, I guess, column and top banner row or whatever you want to call it. And it even says cumulative area from the left. So I would almost say cumulative area to the left of my z-score, if you want to say it that way. But long story short, we have this table here, and there's the picture saying if you're looking at this table and you're looking at one of these z-scores, now how do you find this z-score? That's a good question. You're going to be determining area to the left of whatever that z-score is. Similarly, there's a second page of the table, and this one is the positive z-score. So if you look on the left-hand side, you'll see these are all positives, and if you look on the left-hand side of the first one, you can see they were all negative. So with that being said, let's figure out first, how can I use those tables to answer a question like this? And so, again, there is a STA2023 way, but for now, let's see if we can just figure out how to answer this using what we know. So there's my question. And although that table does work, I'm going to pull up a different one that I end up liking more. All right. So I've got my table, and I've got this picture. And so I'm essentially looking for z equals 0.94, the area to the left of that z-score. So what I'm going to do now is I'm going to look at that table, and I'm going to snip it. Now it's positive 0.94, and then the question is, how do I use this table to determine that? And we'll see. All right. So the way this is going to work is we're going to essentially find the crosshairs of 0.94. So positive 0.94 starts here. Oops. And then, of course, the 0.4 is right here. And so we end up getting a nice crosshair where they intersect. And so we've now found the answer to this question. Where do those two intersect? Right here. And sorry, I kind of blurred it out. But evidently there is 0.8264 area to the left. That's how much is inside of that shaded region. Now, why should that not be too surprising? Let's look back to the empirical rule to see why. This would again be +1 standard deviations entirely, and so if you think about it, we would have had, if I could draw better, we would have had all the 50% down here, and we would have had an additional 34%. So 0.5 and plus 34 would be 84%. So we should have been, since that was 0.9 something, we should have expected to get something near 84% essentially. And take a look, we have that. It's almost exactly 84%. I mean, not almost exactly, but we're within, about 2% away from being that value exactly. So there you go. Now, the other thing we need to address early on is that even though that answer comes directly from the table, you can do this in StatCrunch, but you will get a different actual answer to 4 decimal places but both are considered correct. So that's a little bit of a trip the first time we see it. And let me get my Safari window back, and then we'll show you the StatCrunch way. Alright, so the other way is, of course, going to StatCrunch. And so what we're going to do is we're just going to go to Stat. We're going to go to Calculators and Normal Calculator, because we're on the normal distribution. Now here's the big question is, what am I going to use here? And thankfully it tells you verbally, use the mean of 0 and standard deviation of 1. In other words, use what the table is set up to do. This is just assuming that you have a normal distribution where 0 is in the middle, plus or minus 1, 2, or 3 is on the ends. So we're not being asked to do anything other than use 0 and 1, or use the raw, pure table values. So if the mean is 0 and the standard deviation is worth 1, then what's the likelihood of getting 0.94 and being less than or equal to it? And there's just about the same answer, 0.8264. So I think in either case that actually was the same answer for both. It won't always be, sometimes it can be a little bit off, but those almost both match no matter how you round. So that's kind of nice. Now from there, we're going to do maybe one or two more on the table, but we're really going to lean on StatCrunch because once you use StatCrunch, it goes by super quick, but you still should have some sense of what's going on there. All right. Uh-oh. Snip went away. Okay, next question. Now notice this time, here's the trick here, is the area is going to the right. So that's going to change things. To find the area to the right, I'm still actually going to find the same z-score that's written on here. So I'm going to go to the table, and I'm going to find negative 1.04. Now it's a bummer because the negative 1 is kind of far away, but I want to get the whole table so we can really see what's going on there. All right. But I will have to kind of shrink it down. There we go. So the idea is, there's my negative 1.03. Now there's my negative 1.0. And there's my 0.03. Goodness. And so you can see that they cross at 0.1515. 1.0, and then there's the 0.3. And again, what I'm getting if I crosshairs that is I get 0.1515. But here's where we then need to make a note. Since the table tells area to the left only, we need to find the complement. Alright, so 1 minus 0.1515, and it just so turns out that that's going to be 0.8485. So there we go. We've now found the same, or I guess the right answer by almost doing the same work is what I meant to say, but we just need to do that one final 1 minus, because the table, again, if I pull up the picture, the table will always only tell you area to the left, and so if you want the area to the right, you simply just need to apply the complement or 1 minus your answer. Alright, so 0.8485. And there we go. So now we're going to go the other way. So like I said, we're going to do a few of these without StatCrunch just early on. Let's work through this one. It's still important. Now, I don't like that they don't shade this one, but the concept is still there. Sweet, got it before it disappeared. And I might be able to get away with copying this table again. Awesome. So now the idea is we have the area to the left, and what z-score gives that area to the left. So that's what this is saying. What z-score gives the following area to the left. So again, the bummer is that it doesn't really quite clearly show it's to the left, but you can see there's the cutoff value, and they're putting the writing on the left-hand side. Now, what we can do there is, once again, just look at this table, but we need to realize that we're now doing this in reverse. See, before, we had the z-score on the bottom, and we were looking for the area in the middle. When we had the z-score on the bottom, the 0.94, we looked for 0.94 on the outsides and found the crosshair on the inside of the value we were looking for. Same thing, I had the negative 1.03 as a z-score, so I find negative 1.03. Again, I know that's small, but zoom in on the video if you can, and I'll try to do it here as well just for a moment. But, oh, hello. Well, you get the idea. The 0.1515 is what we're looking for after, but we had the z-score, we had the ends, and we looked in the middle. Well, now then, what are we doing? We're going in the exact opposite order. I see 0.9798, and that is technically area to the left. So I'm using this table, and I'm looking for the closest I can get to 0.9798. And actually, bummer, I thought I had it on this table, but it looks like I'm just a little bit too far off. So let me look here again. Again, in the middle, I'm looking for 0.9798. Notice that on the left-hand side, I don't even get past 0.5. But on this side, I am going to be able to get my 0.9798. So, whoops, I needed more than I thought there. Uh-oh. Goodness. All right. And I will say, even being the professor, it is going to be a little bit annoying juggling through your tabs, but also you do get this sheet printed out if you like using the table, but you can also, of course, just use StatCrunch. We'll still show you how to do that. So, again, I'm looking for 0.9798 in the middle, and we're always looking for as close as we can get to that. It might be below it, it might be above it, but as close as we can get, or it might actually be there. But anyways, 0.9798. There it is exactly. And so now I can see that that's 2.05. And so my z-score then is what I get when I put those together. 2.05. And I'm done. That's all there is to it. Now, of course, what would be tricky is what if you were looking for area on the right? Well, you would do what we did last time, but you would first take the complement of the value that you see, take the complement so that you have a left-sided area, and then still look for that area in the middle, and then see where it came from on the left and on the top. So 2.05 is my answer. Really, at this point, there's one more question, which is area in between, which I'm not too concerned with at the moment, because after all, we do have StatCrunch, and we can just work through that. What I would say is if you did have an area between question, like this, I think that's what it's going to be. Never mind. Let me read through. Greater than, between 0.5 and 2.25. So what will we do for that? Well, between 0.5 and 2.25 looks like that would be that. And then, of course, they want to actually get the correct answer of what is that area. What I'll tell you is, if you were using the table approach, you would find the area to the left of the z-score 0.5 all the way down. You would find the area of the z-score at 2.25 all the way down, and subtract those two values, and you're done. But more so, let's move on to StatCrunch and show you that you can just do that here. What I would do in StatCrunch is I would go to Stat, I would go to Calculators, Normal Calculator, and you can even see there's standard and then there's between. Now my mean and standard deviation are still 0 and 1, even though they look like Celsius. And they wanted between 0.5 and I believe it was 2.25. And so there we go. We get 0.2963. 0.2963. And we're good to go. So it really is as easy as that. You can just get away with using what we call the normal calculator. You can either find area in between or other things. There's a lot of things you can do here, again, just to show some of the other ones we just did. To find the area, right, when we wanted the area that was at, what was it, 0.9798. You can just compute that there as well. You can plug in the answer side and still say I want the area to the left, and you're good to go. You could do the other question we had by finding the area to the right at negative 1.04. And really your clue is, do I get a picture that looks about like what I had in the homework, right? So there's finding the area. Oh, it was negative 1.03, but you get the idea. It was negative 1.03. Look at where that line about is compared to the halfway point, and then double check, does yours look pretty similar to that? If it does, then you probably shaded it in the right direction. Just be careful that you set the shading right. And remember that you could also, again, flip the script. You could say, again, what if I want the area that's 0.6324 greater than, and so there we go. Now I know it's the z-score negative 0.34. So it's a pretty simple table, and especially since all we were using was 0 and 1, and it even handled the between cases as well. With that being said, I guess I don't want to say I hate to say it, but the good news is we really don't have much left to discuss for this part of the video, because 6.2 is, and we're only going to do stat crunch here. Sorry, no, I lied. We're going to do one non-stat crunch question, or maybe two, just to show you how it works. But really, we're going to fly through this super quickly. So the idea is now, hey, what if the mean and standard deviation aren't 0 and 1? What if they're actually some real-life values? What do I do? Great question. So 6.2, that's what it's all about. Using the normal distribution with real-life values. The short answer is just convert to a z-score and still use 0 and 1. In other words, use the table. Or you can use the real-life values in the stat crunch tool. And of course, that would be probably your best bet. But let's show you what I mean by that. And let's recall our z-score formula. It looks like this. It's a z-score is some value compared to the mean and divided by the standard deviation. And when you use this formula, you've converted everything to zeros and ones, and so you can still use the regular, or you've converted the mean to 0 and the standard deviation to be worth 1, and you can still just use the table as normal. So really it just means there's one additional step. So here we go. Let's pull up one example like this. Let me cut off those values real quick. And let's get started. Alright, so we have a mean of 100, standard deviation of 15. I know I cut that off, but that's okay. And then we've got 70. So the first thing to do is to figure out the z-score of 70. So 70 compared to 100 divided by 15, and spoiler alert, that actually is going to work out perfectly to being -2, because that would be -30, and then -30 divided by 15 would just be 2. So, you know, I almost want to change this one because that's too nice of a value. So let's do that. I think I already know what this is going to be. It's going to be point, if I can think about it, 1602, somewhere near there. What am I missing? Oh, never mind. Sorry. 2 standard deviations away. This is going to be about 0.0250. You know, I tried. I'll show you where I was getting that from, and sometimes it still needs to be precise enough. But I just wanted something that had an uglier value. Well, actually, we should just answer the question there now that you're wondering, what did I just do there? So let's just find it right here. Let's grab this table and show you where that exact answer was. I just thought I could guess it using the empirical rule, but what I just taught myself is that the empirical rule wasn't precise enough. So that's a good talking point. I'll cover this up for a minute. But look at negative 2.0. There it was, the 0.0228. So there's that answer right there on the table. Now, why was I wrong, or what was I doing? I was trying to be slick and get away with, hey, if I'm 2 standard deviations away, if you add up all of this data, oh, I see the mental math I did wrong now. I was thinking, oh yeah, 95% is covered between these two and these two. Well, no, I'm not wrong there. Yeah, 95, theoretically, it's an estimate, is covered between here and here. And since I had negative 2 directly and how much is left, well, if 95 was in the middle entirely, then 2.5% is split either way on the sides, and there's the 2.5. They just don't write that extra small percentage there. Now, technically, that is correct thinking, but the idea is now the empirical rule, and maybe here's the point. Maybe I did it on purpose. I didn't, but it makes a good point. But there comes a point where the empirical rule isn't precise enough for your answer. So even though this is exactly negative 2 and negative 2 is on the empirical rule right here, the 2.5 cumulatively all the way to the left here still isn't accurate enough. We need to be closer, and this table gives us that answer right there. I know that one's really small there, but you can pull out the table and see. Okay, so what are we going to do about this? Well, first I want to make sure I zoom in on that. Big enough. Maybe I'll crop it. All right, much better. So there's your 0.0228. So what we learned is the empirical rule is no longer precise enough. So big lesson there that I caught myself on trying to be slick. But ultimately I would have used StatCrunch anyways, and you probably would too. At this point, really, you shouldn't be thinking empirical rule, so maybe we're just making that point one more time. Well, we did an area to the left. Let's go ahead and do area to the right or something like that. But actually, you can see we're already moving a little faster. We're getting to the area between questions, so maybe we'll just go through one more like this. So I want to do this question again on the table to still warm up to the idea. But then we're going to do everything else in StatCrunch super quickly. All right, now I'm going to just say the mean is 100. Standard deviation is 15. I really don't like this section in the book. I know I've harped on your book, but I really don't like it because even though they try to make it real life values, they're always just like 115, and that bothers me. And really, I looked around the book as much as I can. Anyways, when I work this out, that ends up being negative 5 over 15, which would be negative 0.33 repeating. So there's my z-score. And so I'm now going to go to the table and I'm going to find negative 0.33, which is hard to find. Uh-oh. We're going to need to crop that. Give me a second. All right, great. We got it cropped. There's, again, the negative 0.3, and there's the 0.3. And so if we crosshairs those two together, I get 0.3737 as my area. I think the most confusing thing here for students, as a reminder, is what am I looking at? Is this the area in the middle, or is it the stuff on the outside? And remember that the z-scores are on the outsides, and the area is in the middle. So because this was the value underneath the table, I'm using that value underneath and turning it into a z-score. Because this is a z-score, my final answer is the 0.3737, where they overlapped. So 0.3737. Okay, and maybe just to compare that, let's go to StatCrunch and show that the answer might be a little different, and then let's just do StatCrunch for the rest of these really quickly. Because the thing is, StatCrunch doesn't need you to convert this to a z-score. It can just use the 100 and the 15, and I want to be less than 95. There's no work required. And there it is, about 0.3737. That looks a lot different though, doesn't it? But it's still going to be the right answer. So 0.3737. 0.3694. It seems weird that both of those would be allowed. 0.3694. But your homework has some tolerance built in there. Wait, let me make sure I rounded right. Your homework has some tolerance built in to accept both of those answers because they're technically both right, whether you use the precise tool or the good enough table. 0.3694, yep. So let's check it, make sure it's right. I'm just nervous now after that one question. But there we go, it's still correct. And the 0.3737 would work as well. In fact, maybe let's see if we can do that. All right, you would not believe how many times I had to click randomize to get that answer, but let's just see the 0.3707 and see that that's right as well, just in case I want to see it for myself as well. Awesome. So it accepts both the StatCrunch answer or the table answer. Now, obviously, the big benefit about StatCrunch is, if you noticed, you don't actually need to use a z-score at all. You get to plug in the means value and the standard deviations value and move right along. So even for a question like this, where it's a between question, we can say, okay, they told me the mean's 100 and the standard deviation's 15, and I want to know between being 95 and 125. Done. There it is. The 0.5828 is what it rounds to. So super cool that we can just do that. Let's look at a few more here. This one will be fun to do the opposite way, and that would be the other piece of advice is challenge yourself. This one still is a mean of 100 and a standard deviation of 15, but this time you're given the area. So I want this to be 0.8, and I want the area left of that. I want still the less than or equal to, and I can compute that, and I get about 113 when I round to the whole number. Just notice that that's what this is doing, is it is going to switch this around. So if you wrote 0.8 here and you had it flipped around, notice that that's not the same graph or the same picture. So you really should, think about the fact that because that picture is being drawn for you, you can recalibrate it until you get what looks like an exact match to make sure you formatted it right inside of StatCrunch. All right, last one, same idea, but this time again, it is given that the area is the 0.75, and they want the area greater than. And there we go. That looks about like the right match, and that does indeed round to 90. So really, that is 6.1 and 6.2. My, request or desire would be go through the homework, try to really go through it with the table, try to work it out with the z-scores. Again, the one that we didn't do was do a question like this where not only do you find the z-score, but then you turn that z-score using this formula. You know the z-score, you know the mean and standard deviation, but you solve for x, and then that's how you figure out at the end of this question that it's 90. Because first you have to find where is a z-score that has 75% area to the right. In fact, I'm almost going to say it and work it out. 75% area to the right, I can't actually solve that, but I can solve for 25% area on the left, and the closest I can get to 25% area on the left is actually right here. It's not precise, but notice this is 14 above and this is 17 below, perfectly 0.25. So this value, negative 0.67, is your z-score. I guess I'm just doing the problem now. Can't help it. So the, negative 0.67 was the z-score. Let me get those extra text boxes away. Now, because it's your z-score, that's what I have, and I don't know what the value is, but I know it's being compared to 100 and divided by 15. Well, guess what? When you multiply 15 times negative 0.67, you end up with essentially about negative 10. I'm going to say approximately negative 10. I should figure out what it is, but I'm just moving quick for sake of time. Then I still have x minus 100. I should add the 100 over. Again, you should actually work out what that is as a decimal. There's going to be some decimals there. But really, if you work that out, if you add the 100, guess what you get? Approximately 90. And now let's look at what I got for the answer. 90. So StatCrunch can do it, or notice you can still say, if that's my z-score, if I used my table and figured out where 25% area is less, even though they asked for 75% being more, I can't do that on the table, but I can find 25% less. I can then take that z-score that corresponds to 25% less and reverse engineer it with the z-score formula to find the value that was used for this distribution. Now, the one last thing I want to say, because I don't like the way your homework's laid out, I would highly recommend, if we look at math, high school, college, and AP college statistics on khanacademy.com, you can see right around here, and I think it would be, I gotta see where it shows up again. I think it'd be in random variables. Let's see. Sampling distributions. It might just be here. So I'm not going to lie, that was a little bit harder to find. But, ooh, yep, these are exactly the questions I'm looking for. So it's still something that you can do in StatCrunch. In fact, I'm still going to open up StatCrunch to do it. But I really think it's almost worth going through to Khan Academy just once. Really just to see... 1 minute, let me get my windows arranged here. Like I was saying, really just to see other questions that are more interesting, that have more, I want to say ugly real-life numbers, but I've got a SAT score with a mean of 1497 and a standard deviation of 322, and I want, and it's even written right there, greater than a score of 1800, and there it is, 0.1733 or 0.17, because they only want it to 2 decimal places, and there we go. So it's just another way to practice using your StatCrunch calculator, even though your questions are going to be, probably either zeros and ones or 100s and 15s. I really like going through this just to see some more real life examples. So really, the place to go to review that, where was that again? So it was called Probability and Normal Density Curves. Inside of the AP Calculus College Statistics. It's just another place to practice your work. I think even here in z-scores, yep, this would be a good one. So normal distribution, area above and below. Same thing, they use the mean of 70, standard deviation of 4. What about 65? So getting 65 or higher. Same idea. And that's area above or below, so is it going to the right or to the left? Then there's the area between, right? So we did that. Again, you can do that all in StatCrunch, or you find 2 separate z-scores, look up their values in the table twice, and then subtract those 2 values. Or this is where you do it in reverse, where they want the lower 25%. They want that lower 25% cutoff, so that's looking for the 0.25 area in the middle. And then, once again, like we did, reverse engineering. Now my windows are just all gone, but you get the idea. Reverse engineering what that score is that separates the lower 25 from the upper 75. So really good examples to go through there. Again, that might be the better section. It was in AP College Statistics, Unit 4. You can also see there's lots of videos here to watch too. Those would be great as well. But these 3 at the bottom, normal distribution calculations, area above or below, area between, calculations in reverse, there's videos for all of them as well, but you just watched this one. I would highly recommend those as we go through this section. I'll see you for 6.4 and then for Chapter 7.